So let's get into it. Like I said, guys, today we're revising everything that we've done in whole numbers and integers. So nothing here should be new to you. We have done it all already. But let us have a look and see. Hopefully we're feeling comfortable with this section as we go along. Sorry, I just wanted to move this so that we actually have all of our questions in the same place. Alrighty, so let's have a look at example 1 here. Example 1 is saying to us that we have a list of numbers and we now want to fit those numbers into specific categories. Okay, so we've got 3 cubed. Now remember, I've said to you that whenever you get numbers that aren't simplified, try and simplify them for yourself just so that you know what you're working with. So 3 cubed we know is 27. 30 is 30. We don't need to simplify that anymore. -3, 2/5. Square root 3, we can't square root 3. We will get a whole long decimal, so we just need to remember that. 1,3 and then 3 pi. So from this whole list of numbers, what we want to do is we want to find a number that is an integer with factors of 2 and 5. Now let's break down what this means. Remember, an integer are all your whole numbers, which isn't like the best description, but essentially whole numbers, but both positive and negative. So all the way from positive infinity to negative infinity, no decimals, no fractions, just the whole numbers. That's an integer. So we're looking for an integer, so a whole number essentially can be positive or negative, that has factors of 2 and 5. So if we think about our numbers here, we've got 27, and straight off the bat, we should see that 27 definitely doesn't have a factor of 2 because I can't halve it without a decimal. So we can ignore 27. That's our first integer. Our second integer is 30. Now, if we think about all of the factors of 30, and remember, factor is numbers that can divide into the value without a remainder. So as long as we get no remainder, then we should be okay. If we think about 30, we've got lots of factors for 30, but we've got 1, 2, 3, 5, 6, I'm making a little bit, 10, 15, and 30. Those are all of our factors for 30. And now it's told us that we want the number with factors 2 and 5. So in my factors, I can see that it's got factors of 2 and 5. And so the integer I'm wanting here is 30. So we need to read these questions very, very carefully so that we know exactly what it is that we are looking for. Right, so the next one's saying rational numbers that are not integers. Can anyone tell me what a rational number is? Guys, remember we have done this all before. If you're feeling a bit confused, you can get the recordings online. Amatle, what's a rational number?
A number that can be written as a fraction or as a fraction.
Perfect, exactly. So remember, guys, rational numbers are basically numbers that we can write as fractions. So can write as fractions. So essentially what we want to do here is find the ones that we can write as fractions, but are not integers. So aren't those numbers from positive to negative infinity. So Simoniswa, do you want to tell me what those would be? Okay. Lungelo, do you want to tell me what they would be?
Ma'am.
Okay, guys, remember you need to unmute yourselves when I call on you if your hand is up. There's obviously a reason your hand is up. Okay, Simoniswa, do you want to answer? No? Okay. Yeah?
Ma'am, the answer is 2/5 and 1/3.
Okay, good. So our two rational numbers that are not integers is 2/5 because that is a fraction, but it's not an integer, as well as this decimal 1,3. Now we know this can be written as a fraction because whenever we've got a 1 decimal point, we can always write it over 10. So it can be written as a fraction. Doesn't matter that it's an improper fraction, it still can be written as a fraction. Okay, so the next one asks, we want now an integer, but not a whole number. So can someone tell me, you can put your hands up, what is the difference between an integer and a whole number? Longelo, your hand is still up. Do you want to tell me? Okay. Tando, do you want to tell me the difference between an integer and a whole number?
Yes, ma'am.
Okay, I'm ready.
Okay, so the difference is that a whole number is our everyday numbers or counting numbers, including 1 and 0, including 0, and integers are numbers using positives and negatives.
Excellent, well done. So guys, the big difference there is whole numbers are only positive values, whereas integers can be positive or negative. So what we want to do here is we want to look for the negative whole numbers, for lack of a better word. And so if we go back up to our list, we can see that the only negative value that we have is -3. It is an integer because there's no decimals, there's no fractions. And so the value that is an integer, but not a whole number, is -3. Because as we've just been told, whole numbers do not include negatives. So we need to be comfortable with our number system in order to be able to classify types of numbers. And that's why we did a whole lesson on the number system. And like I say, if you are new, remember all of the lessons are recorded and you can get them on the website or on the app. Okay, let's have a look at D. So D is now asking us for a natural number smaller than 10. So who can remind me or who can tell me what a natural number is, just that we know what types of numbers we're working with? Kwanda, do you want to tell me?
Yes, my natural numbers start at 1 and increase to infinity.
Perfect. So 1 to infinity, and very importantly, again, no fractions or anything like that. We can also think of them as our counting numbers. When you learn to count 1, 2, 3, 4, etc., etc. So we want to look at all of these numbers and we want to decide, do we have a natural number that is smaller than 10? Now, think carefully about this. Oh, golly, sorry, everyone. Do we have any? So Moniswa, do we have a number smaller than 10 that is natural?
No.
No, exactly. So we have no value that is from 1 to 10 in our list of numbers. We've got 27, we've got 30, we've got -3, but none of those are natural numbers. So here we would have no answer. And we need to be very careful that we then understand the difference between integers, excuse me, and natural numbers. Right, the last one is then asking for any irrational numbers. So before we decide which ones those are, does someone want to raise their hand and tell me what are irrational numbers? Luciba?
All numbers that are not rational.
Oh, okay, fine. So irrational numbers are essentially our numbers that are not rational. And we know that rational numbers we can write as fractions. So irrational means we can't write them as fractions. So any number that has a whole long decimal that just keeps going, no pattern to the decimal, that is an irrational number. So Yolandi, okay, Yolandi left me. Novuyo, can you tell me which ones are irrational here? Calvin, can you help me?
Ma'am, I wanted to answer at the answer of irrational. What is irrational numbers?
Oh, okay, so we've already answered that. Are you happy with the definition?
Yes, ma'am.
Okay, good. Alrighty, guys. So, Novuyo, which ones are irrational?
Ma'am, I think it's two. No, sorry, ma'am. I think it's 1.3.
Okay, so remember
1,3.
we've already said 1,3 can be written as a fraction. We wrote it over there, 13/10.
Oh,
It's all right. Oratile, do you want to help us out?
Hi, ma'am.
Hi.
Ma'am, I think the irrational number is 3 pi, ma'am, or pi, ma'am.
Okay, good. So guys, remember I said to you, anytime you see a pi, that is irrational. And then very nicely done to those of you in the chat who are saying square root 3. Square root 3 is also irrational. If we found the square root of 3 on the calculator, it gives us this whole long decimal number. So this is 1,732050808, and it actually just keeps going. There's no pattern, there's no end, and so I can't write it as a fraction, which means that it is irrational. Right, so again, go back and have a look at the very first video that we did, or the very first lesson that we did, if you need a bit of a brush up on your types of numbers. Right, I wonder, -3 is not irrational because I can write that as a fraction. -3 I can write as -3/1. And so because I can write it as a fraction, it is rational. Right, it is an integer, so it is rational. I hope I say your name correctly. Rosalind? Rosalind?
It's
Just correct
Rosalind.
me. Rosalind. Okay, thank you.
So ma'am, I just wanted to know if an irrational number is like an inconsistent decimal.
Yes, basically, exactly that.
Okay,
Good.
thank you, ma'am.
Right, guys, I'm just waiting here in case you want to take screenshots of everything that's there. So, Monisa, do you have a question?
I think there's also one more.
Which one do you think?
I think 3/3.
Sorry, which one?
3/2. 3 cubed.
3 cubed, remember we've said is 27, which means it is a rational number because I can write it as a fraction. 27/1.
Okay, ma'am.
Okay, guys, I'm assuming, excuse me, you all have your screenshots. Oh, no, okay. Right. So let's move on to our next example. Give myself so much space. So what we've also spoken about is being able to simplify expressions. And so what we really need to take note of here when we simplifying expressions is our order of work. And now this is where we use bedmas. Some of you use bodmas. That's absolutely fine. Whatever you want. I prefer bedmas because this E reminds me that we are talking about exponents. Right, B is brackets, so whatever is in brackets we need to deal with first. Draw some better brackets there. Then we've got division, multiplication, addition, and subtraction. And what you need to remember is that there's levels of importance. So the brackets must happen first, then the exponents, then any division and multiplication, and then only right at the end do we deal with any addition or subtraction. Okay, now we did chat about an example like this when we did this sort of concept or this topic, but I just want to remind you, if we have a look at A, so I'm just to make this a little bit bigger, when we have a situation of a plus and minus right next to each other, remember there is technically a ghost or an invisible 1 in front of that bracket. And so what's actually happening here is we've got +1 times a -9. And we know that when we multiply a positive with a negative, we end up with a negative sign. And this is taking us back to our little rhyme of SNV, which when we multiply or divide, we consider the signs, we consider the numbers, and if there are variables, which we'll get to in algebra, we consider the variables. So positive times a negative is a negative. We've sorted the sign. And then we've got 1 times 9. And so we end up here with a -9. And so what we need to remember is that when we've got a plus and a minus sitting right next to each other, that sign becomes minus. So have a think about this question. What I'll do is I'll rewrite it with our sign now sorted. So we have 17 minus 9. And can someone put in the chat, or you can raise your hand, what is our answer to 17 minus 9? Timothy, do you want to help us here?
8, miss.
Perfect. 17 minus 9 is +8. Very nicely done. And guys, remember, you need to be careful if there is a sign. In this case, it's positive, so we don't have to write +8. We just write 8. But remember, if there is a negative somewhere, remember to put that in so that we are working with the correct term. Simboniso, do you have a question?
I just wanted to answer number A.
Okay. Alrighty, guys. So I want you to try, I want you to try question B by yourself. So question B, -24 minus 15 plus 3. Muniwe, do you have a question? Muniwe, are you there? Okay, I'm liking what I'm seeing in the chat. Anyone want to raise their hand and let me know the answer? Nicely done though, guys. Asande? Oh, no. Amatle, what is the answer? Oh, no. Asande, are you there?
I'm here.
Okay, what is the answer?
A -36.
Perfect. -36. Now, guys, if you need to do this in steps, do that. There's no need to go and rush and do it all at once. So if you want to first deal with the subtraction of the first 2 terms, let's do that. -24 minus 15 gives me -39. And then in your next step, you can add the 3 to give you -36. If you need to do more working out, or if you need to do more steps, do that. That's absolutely fine. All right. Boniwe, we didn't say 18 minus 9 because the question was 17 minus 9. So there wasn't an 18 there that we were working with. Right, I'm waiting here for you to screenshot. Somebody, do you have a question?
Ma'am, it's pronounced as Mboniswa. Ma'am,
Say again?
it's pronounced as Mboniswa.
Simoniswa.
Mboniswa, ma'am. Without the is.
Oh, okay. Okay. Thank you. Thank you. Mboniswa.
Ma'am, by -39 plus 3, how do you get 36?
Because remember, if we're working, or if we think about a number line, if we're sitting at -39 and we want to add 3, we want to move up our number line towards positive infinity. So we will jump 3 steps up our number line in order to add. So 1, 2, 3, leaving me at negative 36.
Thank you, ma'am.
Does that make sense?
Yes,
Good.
ma'am.
Perfect. Alrighty, so just to go back to question A, this positive 1 here, guys, is not, okay, maybe it's too confusing to think of it like that. All you need to remember here is that when you've got a plus and minus right next to each other, there's a negative. The reason is because technically there is a 1 in front here that needs to multiply into the bracket. But remember, multiplication happens first. You never add first and then multiply. And so that's why it's not going to be 18, because we will never ever add first. We will always do the multiplication one. So you don't have to have the 1 there. That's fine. You can ignore the 1. What you need to remember is the plus minus situation becomes negative. Okay, so what I'll do is I'll leave those 2 up there like that. Let's leave bedmas or bedmas there. And what I want you guys to try for me by yourselves is question C and question D. If you're going to put your answers in the chat, please remember to label them like Mboniswa has done. C is, or C whatever, just so that we know which answers you're talking about. Remember bedmas or bedmas. Like I said, I prefer bedmas. I'm going to give you guys a minute or 2 to try those, and then I'll take some answers. So remember your order of operations. Sorry. Remember your order of operations. Remember to do more working out than you might think is necessary so that you feel comfortable and confident with your answers. Okay. I'm just going to scroll like this so we can start to see what we're working with. Doing really nicely, guys. Excuse me. Okay, I'm going to give you another few seconds. Okay, Lufuno, do you want to tell me how we do C?
Yes, ma'am.
Okay, I'm ready.
And the answer to C, ma'am, is -2.
Okay, can you tell me the steps that you did?
Ma'am, I started with the bracket, ma'am. I said -10 plus 5, which is equals to -5. Then I said -3 minus -5, which was 2. And then I said +2 minus 4.
Okay, perfect. Right, so guys, what I just want to quickly chat about here is that whole negative situation that Lufuno told us about in our expression. Now, this is quite similar to this question A. There are 2 signs right next to each other. And so here, when we've got a negative, we know that negative times a negative is a positive. And so what we actually have is -3 plus 5 minus 4. And so that's where, when Lufuno was saying 2, that's where we get 2 from. I'm just going to take this off quickly. I need some more space. -3 plus 5, if we do it step by step, is +2. And then +2 minus 4 gives us that -2 that Lufuno gave us as an answer. And so what you need to be careful of here, as I was saying, is your signs. Always double check your signs when you are simplifying expressions. Right, are there no hands for D? Ooh. Anyone feeling brave and would like to try D? Nice. Wanga, do you want to explain D for us?
So, ma'am, D is -8.
Perfect. Right, so guys, what we need to remember here is if you wanted to, any division can always be written as a fraction. You don't have to write it as a fraction. But what I need you to remember is that the sign rules of multiplication apply for division as well. And what I mean by that is if we've got a positive value, so 56, divided by a negative value, we are going to get a negative answer. And so exactly, positive 56 divided by -7 is -8 because we have a positive divided by a negative. And so once again, you really need to be careful with your signs. And I'm harping on about signs because not even half an hour ago, I sat for about 20 minutes trying to figure out this matric sum, and my mistake was a sign. And so often where we go wrong is signs. So we always need to double check our signs. Alrighty, gonna wait there for you to take a screenshot if you want. Mboniswa, do you have a question?
I just wanted to say, how did you get to -8?
Okay, so -8, all I'm doing is I'm saying 56 divided by 7. If you go the other way, we know that 7 times 8, if you think about your times tables, 7 times 8 gives us 56. And because it's a -7, we essentially have a negative answer that we're working with.
Okay.
Good, well done. Righty guys, so take your screenshots. We're going to take a little break now. And remember, when you're doing questions like A, B, C, and D, bedmas. Alrighty. Here's your brain break. I hope you enjoy my math joke because I tried really hard to find one that had something to do with the number system. I don't know if anyone remembers when we did chat about numbers, I told you that there was a whole set of numbers, or was a whole other number system where we work with non-real numbers. Now, if you type on your calculator the square root of -1, your calculator gives you a math error. And the square root of -1 is actually I. And I is one of our more famous non-real numbers. So that's why this I is being told to get real, because it's a non-real number. Okay, so brain break, for those of you that are new, just so that you understand how a brain break works. Why do I feel like we've done this already? Have we done it? I'm losing my mind.
Didn't we do it with the
Oh.
grade, with the standard class? Not with this class.
Maybe. Okay, if you're saying no, I'm going to take it. Right. That's great. Brain break. What we do here is we basically want to solve the equation essentially. So we want to know what the value of the guitar, the trumpet, and the banjo is so that all of those answers are true. So think of it like an equation. You're solving an equation for an unknown. And so give it a try and see if you can get the values of those instruments. I'm going to give everyone a chance. Ndalo and Mboniswa, I see your hands, but I'm just giving everyone a second to think about it, and then I'll take some answers. Nice, guys. And remember, once you know one, you can move on to the next one to then get the next unknown or the next instrument. Remember your order of operations. Again, Just like we've been doing now, order of operations is really important. Yeah, does anyone play any instruments? I wish I could play a musical instrument. I used to play the violin when I was little, but I wasn't very good. That sounded like a cat crying.
But that was awesome. I mean, that would be awesome to learn to play any instrument. Oh, Eddie
Tell us
plays
what
a
instruments
guitar.
you guys play.
Yeah, Eddie plays a guitar.
Piano.
Oh, fancy.
There are so many piano players. We can form a band.
The drums.
Really cool. I want to learn to play the cello.
Yeah.
You don't have to be the
Maybe
best,
you could
Eddie.
be the
You just have to
piano.
enjoy it. I don't think I've got the hand-eye coordination for a piano.
Yeah,
Oh,
but
and marimbas. I love marimbas. Oh, and Tando can sing. My dream. I
Wow.
wish.
I can't even sing to save myself. Like, I'm a terrible
No,
singer.
exactly.
One of these days, Tando, we're gonna ask you to sing for us at the beginning. Or we're gonna have our own slogan or something. With the foundation.
I agree.
Okay.
I see so many hands. This is awesome, guys. Okay, Jabu, do you want to help us with the first equation? Jabu, you there?
The number's 8.
Okay, perfect. So for this first one, for the guitars, we know that the value that we are working with is 8. And guys, what that means, sorry, Jabu, I'm just clicking things, you can ignore me. What that means is every time we see a single guitar, we know that the value is 8. We need to be careful at the end here because we've got 2 guitars, but we'll get there in a second. Right, very nicely done. Uma, do you want to help us with the second equation? Uma, are you there?
The trumpet is equal to 24. And
Okay, so let's just double check the trumpet here. So if we take this equation and we replace the trumpet with x, because that's really all we're doing. We've got x times 8 plus 8 equals 40. Now we know that x times 8 is 8x plus 8 equals 40. And so what we can do is we can solve the equation. If I subtract 8 on both sides, I'm going to have 8x is equal to 32. And then to solve for x, so to solve for my trumpet horn thing, what I would do is I would divide both sides by 8. And we know that 32 divided by 8 is 4. And so now we know that our trumpet here has a value of 4. So remember, guys, you can always set up an equation for yourself if you want. You don't have to try and do this without. You can use algebra if you would prefer to use algebra. Because that's really all this is. It's an equation. Okay. So, Evile, do you want to help us with the third one?
Yes, ma'am.
Okay, I'm ready.
The third one is 100 times 1 plus 4.
Okay, so remember, we've got 2 trumpets here. And so they have to be the same value. And because we know that the trumpet is 4, if we've now got 2, we know that each of those are 8. Do you agree?
Yes, ma'am.
Okay, good. And so now, again, if we wanted to, we could set up an equation. We have got the banjos, so let's call that our X now, times the 2 trumpets, plus 8 equals 104. So we can now go and try and figure out what the double banjo is. Do you want to try it again?
Okay.
I can ask someone else if you don't want to.
Okay, ma'am.
Okay, well done though. Edie, do you want to help me with this one?
Yes, ma'am.
Okay.
So the banjo would be 12, the 2 of them.
Mm-hmm.
And then if you say 12 times A plus 8, you get 104.
Exactly. So if we sort of solve our equation, we get that the double banjo there is 12. And so now we've got everything we need in our last equation there. So Clement, do you want to help me with the last one? What's the value of the last equation?
Ma'am,
Mm-hmm.
yeah, I'm not sure.
Okay, well, can you help me with this? If one guitar is 8, what is 2 guitars worth? So if 1 is 8, what is 2 worth?
What is what?
If one guitar is 8, how much is 2 guitars then?
1.
So we just want to double 8. What's double of 8?
Is it not 16, I think?
Yes, excellent. Well done. Okay, so guys, Clemens helped us out because this was the only bit of information that we were missing here, in that the 2 guitars together are then 16. Now, what we need to be careful of when we are doing this is that multiplication has to happen first. So according to bedmas, we need to multiply first in order to get our answer. So Ndalo, do you want to help me to get the answer here?
Yes, ma'am. Ma'am,
Okay, I'm ready.
196.
Perfect, well done. So guys, 12 times 16 is 192. And then if we add on that 4, that is our trumpet, we get 196. Very well done, guys. And so just remember, these things are like equations. If you can solve an equation, which I'm sure you all know how to do, and we will eventually do equations, so you'll get more practice, all we're doing here is solving an equation. Right, so if you want to take a screenshot, I'll leave it up there for you for a second, but I'm not going to what am I saying? I'm not going to wait for very long, and then we're going to carry on with some questions. Right. So let's have a look at some fractions, because fractions, I think, is one of those sections that we love to hate, we sometimes struggle with, but it is so important that we're comfortable with fractions, because fractions are going to come up pretty much for the rest of maths. So we really need to be comfortable with fractions and comfortable with being able to add fractions, multiply fractions, all of the operations we need to be able to do. So you can have a look at these, but my first question to you is, when we add or subtract fractions, what is the one thing we need to have before we start adding or subtracting? Take a think. What is the one thing that we need? Nice. Lots of hands, like it. Lufuno, what do we need?
Ma'am, the denominators must be the same, ma'am.
Exactly, excellent. So guys, when we are adding or subtracting fractions, I'm just clicking things. So if you see unmute or mute on your side, just ignore me. When we are adding or subtracting fractions, we have to have an LCD. Now, this is only when we add or subtract. When we multiply or divide, we don't need an LCD. And that's really important to remember. We don't want to do extra work for no reason. So only when we add or subtract do we need to have an LCD. That is the only time. Now, LCD stands for lowest common denominator. And so basically, the denominators must be the same. Remember, denominator in a fraction is the bottom number. So the bottom numbers must be the same. Sometimes it will be the same already. So something like question A, your denominators are already the same, so you don't need to stress, but they aren't always. And so we need to just make sure that we know what's going on. Right, Clement, do you want to help with the first one? Because this one's hopefully nice and easy.
Ma'am, let me try.
Okay.
So I must answer for A.
Yeah.
Okay. Just give me a second.
Okay, take a second and try it. You can check your answer as I go along. So guys, when we've got something like this and the denominators are the same, basically what we do is then we just add or subtract the numerators, because having the same denominator means we can write it as one fraction. So now we need to subtract 5 minus 7, which we know gives us a -2. And very importantly, as Eddie has put there on the chat, we always need to simplify our answers. Always, always, always. It's not an option. You have to simplify. Oh, for heaven's sakes. So this needs to be simplified. Now, when we simplify a fraction, we need to ask ourselves, can I divide a value into both the top and the bottom without a remainder? And in this case, the answer is yes. I can divide both of these values by +2, and so I can simplify my fraction. So -2 divided by 2 is that -1, and 8 divided by 2 is 4. And so our simplified answer here, and always needs to be simplified, is -1/4, or -1/4. Now you could write that as a decimal if you wanted to. I personally don't like decimals, so I never really write anything as a decimal unless I have to. But you could write that as -0.25. That's fine. It is exactly the same answer. Like I said, I just personally don't like decimals, but it is the same thing. Right, so really importantly, whenever we're working with fractions, simplify. And if we are adding or subtracting, we need to have an LCD. Okay, all of those hands, if you're wanting to answer B, I don't want an answer. I just want to explain a couple of things so you can lower them. If your hand is up to ask a question, you can leave it up. Okay, cool. There's just a couple of things I want to explain here before we try B here. So if we have a look at B, I'm just going to move over a bit. I'll come back to A if you want to take a screenshot when we're done with B. If we look at B, what we need to be careful of is the fact that I've got mixed numbers. Now, again, personally, I don't like mixed numbers. And whenever we're adding or subtracting fractions, whilst you can add and subtract fractions with mixed numbers, there's nothing wrong with that. Sometimes it's easier to convert it to an improper fraction. Right, again, you need to find the method that works for you. I think converting to an improper fraction makes life easier. So we know to convert to an improper fraction, we take the denominator and times it by the whole number. So in this case, 2 times 5. And then we add the numerator. So 2 times 5 is 10. 10 plus 3, 13 over 5. And we do exactly the same thing with the second one. 1 times 3 is 3, plus 1 is 4. So we've got 4 over 3. And this helps me now because now I can say, okay, I've got my fractions. What is my LCD? Now your LCD here, remember, we want to make both of the denominators the same. So we want to sort of think to ourselves, what is the smallest number both 5 and 3 can divide into? Now, if we think about 5 and 3, the smallest number that they can both divide into, very important, both divide into, is 15. You can think of it like an LCM, right? LCM, lowest common multiple, the smallest number that they both, or the numbers that we're working with, can divide into. So we now want to make these denominators both 15. And to change a denominator, to make it the denominator is the LCD, we generally times. So I'm going to say to myself, okay, well, I know if I times 5 by 3, I'm going to get 15. But remember, what you do at the bottom, you must do at the top. So we will times 13 by 15, not 13 by 3. For my second fraction, I know that if I times 3 by 5, I'll get 15. But I need to do that to my numerator as well. What you do to the bottom, you have to do to the top in order to keep the fraction representing the same amount. So 13 times 3 is 39 over 15 plus 20 over 15. And now, guys, remember, same denominator. You can write it all as one fraction. And then all we need to do is add our numerators. 39 plus 20 is 59. 59 over 15 is our final answer. Now, I've showed you this before, but if you are ever confused about whether or not you can simplify a fraction, if you type it in on your calculator, so here, of course you can't see anything, I've typed in 59 over 15. Your calculator automatically gives you the simplified answer. So you can see it hasn't changed at all. It stayed 59 over 15. And so I know that I can't simplify further. It is what it is. So you can always double check simplification with your calculator. Alrighty. So guys, I'm just going to do this in case you want to take screenshots of those two. Eddie, your hand is up. Do you have a question?
Yes, ma'am.
Yeah.
What would it be if it was 15 over 59?
What do you mean, what would it be?
Like, could you simplify it more?
No. There's no number that can divide into both 59 and 15. 59 is a prime number. So that means that it only has 1 and itself as a factor. And because 59 can't divide into 15, we can't simplify.
Okay, thanks.
Good. Evile, question?
Ma'am, I wanted to ask what happens if our answer is improper and we have to change it into a proper fraction?
Okay, so we can't go from an improper to a proper, but we can go from an improper to a mixed number. So if we want to go to a mixed number, we need to figure out how many times 15 can divide into 59. But again, your calculator does this for you. So if you type it in on your calculator and then you go and push shift, shift, and then the SD button, your calculator automatically converts it for you. So if we think about this, this answer is then 3 and 14 15ths. 3 15s is 45, and then it's another 14 to get to 59. So you can always use your calculator to convert, but you would only really convert an improper to a mixed number.
Okay, ma'am. Thank you.